Hello, I'm Roberto Polesel, CEO of Euclid Labs, and I'm going to discuss a few arguments about the future of robotics with CEO and CTO of several companies. I will let my guest of today introduce himself.
Hello, my name is Herbert ten Have. I'm the CEO of Fizyr, a computer vision company in the Netherlands.
Oh, I forgot to say we are based in Italy. We both have to do something with 3D vision that many times is confused. I would like Herbert to tell us how you define the pain you solve.
Okay, so if you pick known items, let's say a pencil or a phone, something that is always the same, you can program it. So like Euclid and other companies are doing. But however, if you want to pick up something that's always different, like this, every time I drop it, it will be different. So you cannot program how it looks like. So that's in logistics. There's always unknown boxes, unknown bags, etc. in parcel handling. So what we've done, we created a neural network with deep learning to generalize. Like a kid, it can pick a box or a bag or an envelope it has never seen before, but it can still grasp it. So we've trained a neural network to deal with unknown objects, so a robot can pick them, singulate them from bulk.
Very clear. Just one more point. How accurate do you need to be in placing normally?
Okay, so there are two disciplines. One is picking from bulk, either from static or from a conveyor. And the second part is placing or even stacking. Stacking meaning like playing Tetris. What did I grasp and where can I stack it to play Tetris? And that all depends on the camera and on the speed and on the gripper, etc. But
on
it can be
very the first number that came to you as a normal experience.
Oh no! If the camera is millimeter or sub-millimeter accuracy, the software can be as accurate as well.
No. In placing, I mean, the place where you put stuff.
Yes.
Is it a mask? Because you don't know the object. So I expect you place the object in the best possible way, which is not so strict. Am I right or wrong?
What we do with placement is that we simulate an object from bulk, and then we see all the dimensions of the object, and then we see how it's attached to the robot. Like
this, yeah, somehow you're placing the bounding box of the object. Somehow.
Exactly.
Right.
Yeah.
Perfect. So this is often referred as beam picking, and now I will tell you also what we do is often referred as beam picking, and the difference is that the object we have to pick, we know everything about. Is mostly a mechanical part where we have a beautiful 3D CAD file, and we are required to pick it in a very specific way because often you cannot touch all the object and to place it with high accuracy and specific orientation. So we deal with very well-known object on a very strict, demanding accuracy in placing. So we are asked to place in a specific way, which means that, for example, the gripper we will be using will be probably completely different. I guess you need a very generic gripper and you will prefer vacuum every time you can. I'm right?
Yep, correct.
We want as much as possible a mechanical gripping because we need to be sure that the part does not move when we move it around and that we normally match another fixture on the other side. So the same name is applied to very different application of what it looks the same task for a human, but it's completely different how you address it then numerically into a computer. May I ask what is for you on your side of the problem? Because I see our companies as the kind of extreme. Many companies are doing both. We only do the machining stuff, starting from drawing, and we want to be the best one on that. And I called you because I think you have the best solution on the other side. So what is the main obstacle in diffusing, in the adoption of your technology in the world? What do you think?
Okay. So good question. So there are a few components. First component is computer vision, which consists of do you have a good camera that can see the items in the space? Do you have good lighting, etc., and our software? So it's the first is the computer vision part of the solution. The second part is having an end effector that can cope with the variation of the objects you were to expect it. Take a warehouse, like say Amazon or others, they have a huge variation of products. So you can never grasp everything with the same gripper. There is no universal gripper like we humans have two hands. So the first challenge is computer vision, camera and software. The second challenge is coping with variation with the end effector. And the third one is the integration. It's all about the speed, acceleration, deceleration, safety, distances, and all that stuff of people. So those are the three main challenges. And the second and the third are really valid as well.
Now we are very similar, but I think on the camera side, except for very shiny objects, we have plenty of solutions today. There may be some issue with cycle time, depending on the technology you adopt. What is your normal required cycle time from your customer? What is the market asking you the market?
It differs.
Do you have a range?
Yeah, let's say normally a few seconds, 2-3 seconds for a cycle. That could be because it's like singulation and putting it on an induct on a conveyor. So it's relatively simple. Normally we do the complete processing of both the camera and our software in less than 600 milliseconds. The complete process, camera plus our software.
Okay, so just to compare, at the moment we are mostly working in cycles between 8 to 15 seconds.
Wow.
And the point is that if you are slower, you may have other more effective economical solution. And the same if you are faster. We can go faster, but then it's probably a machine with a very long production. And so we go and compare to vibrational unit, for example. So there is a sweet spot at the moment. We are increasing the number of solutions to have a better market fit. But for us, one of the point is that since there is a few numbers of way we can pick an object, and we are limited, every time the gripper design does not give us good solutions, we process a lot of bad ones before. So we can see parts very quickly, but it's not sure that we can pick that part. We have to go to the next one. So one of the big danger is that if we deal with a bad global design, our cycle time will be not constant, and we need a buffer for that. But yeah, you are trying to go very fast. Your design may be also a little more flexible if you go to a conveyor. Our target at the end is a machine, which is normally big and already there. So we have limited improvement we can do on the layout.
Yeah, we always have to replace humans. So we replace humans for doing the picking, and a human can pick easily, let's say, 800 items per hour, but often 1400, 1500, 1600. So in order to be a business case, they want us to be in that area. That's why.
Yeah, our case is slightly different because normally there will be, in any case, a robot, but the way the robot is working will be different. So we are required normally to be more flexible than other technologies and as fast as the others, but the timing comes from the particular process. So when we load billets on a heating system, there is no way you can go faster than the process. So no one cares, but they want to be able to change the product in, let's say, 30 seconds. So you need to be very flexible in adapting. And for example, one of our arguments in selling is that we use less space than other technology. So we are replacing mechanical devices that takes a long path to align with something very narrow. And so, you know, we have a couple of customers with 20, 25 systems. We saved them a new building. The old technology will have required a new building, so it's a different kind. It's not only the human level. It's a different. At the beginning, I was not aware of that. I was thinking we were comparing to humans, but that's not the way. We are comparing to a different work organization. So it's more sophisticated.
Interesting. Yeah. In our case, there is often there are no humans doing the work anymore, or it has to be done also at night. So they really want to automate this.
I absolutely get the point, and you can. There are a bunch of books about how hard it is to work into Amazon, and I am waiting the day they will be replaced on. We want back our Amazon job that the robot has just taken. I think so. We will see the comparison a long time. I have a last question. How many times are you working with the? What is your installed base, more or less, if you can say that, and how much of that is with cobots?
Oh,
the reason is that I will be in these dialogues investigating the future of robotics, and I'm on one of the few with a little, let's say, expectation from cobots on the short term. So I'm on the other side. Normally.
No, I think I will agree. So we are currently having about 20 integrators worldwide, and it depends per integrator. I think the only one that works with cobots always is Van der Lande, which is part of Toyota, and all the others use industrial robots, either Delta, Cartesian, or Scara. So for us, it doesn't matter what kind of robot they use, but I would say, because it's all industrial, they all go for industrial robots and not for cobots.
Okay, it's my experience too. We have several hundreds of beam picking system loading machines, and the number of cobots we have on the field is 0. But we do support them, and we have been in the trade show with them a few times. The problem is that when you always try to get the maximum from the robot. So even if we have 15 seconds, probably they ask us to use the robot to do other tasks. At that point, you have to be fast. And then we are often attached to a machine that cannot be unfenced anyway. So the pressure on speed and price will lead both on the same way, which is on industrial robots. And I'm asking this around because if you go to a trade show today, it looks like cobots are 50% of the world, but in my experience, they're still very low number.
No, I agree.
Okay.
I've got a final remark for your audience. Is that I think when they want to do bin picking, we always tell them go first to a company like Euclid, because you are dealing with these known objects. But if the objects vary in shape, size, color, material, or how it's stacked, this is something that's really, if it's unknown, then it becomes and certainly in logistics, we love it, and we think we want to play a role in that.
Perfect. Thank you very much for your time and valuable answers. See you.
It was my pleasure.
Bye-bye.
Fizyr is a spin-off of the University Delft by Professor Martijn Wisse, robotics professor. We create algorithms to enable robots to cope with unknown objects. Our software enables a robot to pick unknown parcels and items, and it's being used globally in all continents in the world. At least we know there is a big demand for our type of solution, so we're very happy with our clients, and they take us along. I think at the moment we are now facing the first, let's say, 12 to 20 installations, but it will soon wrap up. And I think a substantial part of the work that's now being done in logistics will be automated with robotics in the next 2-3 years. So looking at our company, we are currently quite well positioned to take a big stake of that part of that market.